So the last new topic that we're going to talk about this week is called sine law. So sine law is a way that you can find angles and side lengths when you don't have a right angle triangle. So let's make a note of that there. Not for right angle triangles. We already know our two strategies for right angle triangles. So now we need to try a strategy for when it isn't. So we have this fun little equation over here on the left that says A over sine A equals B over sine B equals C over sine C. So it's called the sine law because we're only using sine in here. We don't have to choose between sine, cos, and tan. We already know it's going to be with sine. And we also know that because they're all fractions here with equal signs, we're going to end up using cross multiplication again. It doesn't go away. But let's talk about what this means. Little a is related to capital A because your capital letters are always going to be the angles. If you see capital, capital, capital. And then the little lowercase letter is the side length that's across from that angle. So notice how little a is across from capital A, little b is across from capital B, and little c is across from capital C. So that's how you can label your triangles. And that's how it refers, that's how you know to use which letter goes where in these formulas. You'll also see on the left here that you can flip around that whole equation and it still is the same thing. So we can do sine A over A equals sine B over B equals sine C over C. Doesn't really matter. I'm going to stick with the first one, but it doesn't matter. So the sine law is used when you don't have a right angle triangle, but you do have two angle measures and one side measure. The side measure must be opposite a known angle, which basically means you need to have two matching pairs. For example, let's label this triangle here. I'm going to label this A, B, C. Let's call this, I don't know, 30 degrees, and let's call this up here 80 degrees, sure, and I'm just going to make up some numbers here. Let's call this 12 centimeters, and let's call this x because we don't know. So this matching pair thing I'm talking about is that we need to have big B and little b here. That's a matching pair where we know a side length and the matching angle. And then we have another kind of matching pair where we know the angle, but we are missing one piece of information. But if we have 3 out of 4 pieces, so here's our 1, 2, 3, 4, from those two matching pairs, 3 pieces of info, 3 out of 4, then we know that we can solve using one of those ratios above. The same thing is going to work down here, so I'm going to label it A, B, and C again. Let's say I have 12 centimeters, and now I have 9 centimeters here, and I'm going to say that's 30 degrees, but we don't know the top one. So again, we have a matching pair for sure with both pieces of information right here. Check, check, angle and side length. And here's our matching pair here. We have the side length, but we are missing the angle. So we still, again, have 3 out of 4 pieces of information. So that's when we know we can use sine law, if we can kind of connect those circles. And honestly, I would always draw those circles. I think it's really helpful. And we'll see that in the next example. When we try to solve it, like what strategy do we use? So let's take a look and see how this works and how do we plug it into our calculator. So example 1 says use the sine law to find the value of A in the following triangle. So here's A, and it looks like it's pretty much almost labeled. But as always, let's do our step 1 of labeling. So we have capital A, angle A, perfect, capital B, and we'll call this little b. So let's see if we can find some matching pairs here. It looks like we have a perfect pair with capital B and little b because we have 40 degrees and the opposite side length. And we have big A and we're looking for little a, so that's perfect. That's 1, 2, 3, 4 pieces. So let's put it together. And before on the other page when we saw that fraction, it said A over sine A equals B over sine B equals C over sine C. But what that just means is that those ratios are for all 3 pairs of side lengths and angles are equal, but we don't need to use all those when we solve it. We only need to pick 2. So in our question, we have a matching pair of A and a matching pair of B, so we only actually need to use this part. This isn't relevant anymore. So just 2 need to be equal. So let's start filling in what we know then. We know that little a is what we are missing, and sine A is, well, A is 30, so we're going to say sine 30. And little b is 5, and capital B is 40, so we can say sine 40. I think what I'm going to do to make it easier for you is say, let's just put everything as a decimal. So we don't know a yet, but we can plug in sine 30, and it is 0.5. The 5 on the top stays. Let's plug in sine 40, and it's going to be a not nice decimal, but that's okay. 6, 4, 2, 8. So that's when we get to do our cross multiplying, because we're trying to get a by itself. That's the goal, but before we can do that, we're going to do our cross multiplying. So if we go across, we'll do the one with a. A times 0.6428 just comes together to be a times 0.6428. And on the other side, 0.5 times 5 is 2.5. So now we have no more fractions anymore. That's the point of cross multiplying, right? Getting rid of those fractions. But we're still trying to get this a by itself. So it's attached to 0.6428. So we need to do the opposite, divide by 0.6428 to get rid of it. We do that on both sides to keep it balanced. And let's see what happens here. Plug it into your calculator. 2.5 divided by 0.6428. You get 3. Let's do one decimal place, 3.9 centimeters. So you should also get that when you plug it into your calculator. Again, email me if you're having trouble with that. So that's how it's going to work if you are solving for a side length. You have to cross multiply, and usually you have to, whatever's beside your variable, whether it's a, b, c, x, y, it doesn't matter what the letter is, whatever it is beside, by multiplication, you need to divide on both sides to get it by itself. So let's try an example now of what if we actually have to find an angle here. So we have a new triangle, JKL. It doesn't matter that it's not ABC. It's still the same kind of idea. So we can do our labeling again and say here's J and little j, K and little k, capital L and little l. And we're going to look for our matching pairs. It looks like we have a perfect matching pair with K. So I'm going to say K over sine capital K equals, what other matching pair? Well, we know we're looking for angle L, and we have the opposite side length, so that's perfect. So equals little l over sine L. So same idea as before, we're just not using ABC anymore. That's okay. So let's fill in what we know. We know that little k is 4 over sine capital K is 20 equals 3 over sine of theta, because we don't know what that is yet. So that's why this one's a little bit trickier. So we're going to do our cross multiplying and see what happens. Actually, let's put our decimal in first just to help you out here. So sine 20, plug that into your calculator, and we will get 4 over 0.3420 equals 3 over sine theta. So we're almost there. And now we can do our cross multiplying. So we know that 4 times sine theta is just going to, we'll just stick them together, 4 sine theta. I'll put that in brackets. And 3 times 0.3420, let's see, you should get 1.026, which is good. And right now, the goal is, I'm trying to get sine theta by itself, which means I stuck to the 4. We need that 4 gone. So we're going to divide both sides by 4 and see what happens. I'm going to move it over here. So we should now have sine theta by itself. And on the other side, if you do in your calculator 1.026 divided by 4, you should get 0.25. And now this is the easy part because you know how to do this. You know how to handle it. We're trying to get theta by itself. Remember that when you're solving for an angle, you have to press that special button. So you need to go the second function to get your sine inverse. 0.2565. Let's see. Sine inverse. Remember that second function. And you should get, if we round it, 15 degrees. So did that take a lot of steps? Yes. Are you going to like it? Probably not. But once you get to the angle, you feel so accomplished. So hopefully this makes sense and you can handle it. It's just that you have to show a lot of work to get there. But you can do this. So example 3, I'm going to leave you to try on your own. I'm just going to help you set it up. When it says solve ABC, it means find all the rest of the missing information. The rest of the missing angles and sides. So let's draw a triangle, any triangle, and we're going to label it A, B, and C. Doesn't need to be accurate. And we want to fill in the stuff that they give you. So it says angle C is 60. So we're going to plug that in. There you go. Angle B is 20 degrees, which is amazing. You know that you can find angle A without having to do even trig. You can just remind yourself that all the angles in a triangle have to add up to 180 degrees. So remind yourself of that to find angle A. And the last thing they give us is that side C, little c. So remembering that if we label our triangle, capital A, capital B, capital C, little c. And it says little c is 5 centimeters. So let's put that in here, 5 centimeters. So your job now is find angle A, and side B using your sine law. Good luck. I know you can do it. And good luck on your quiz. That is whenever you finish all this stuff and you feel confident.